So basically, problem 2.1, we start out with an ideal gas at a given temperature, volume, pressure, and we want to find said quantities, the volume, the work, the heat, the change in the internal energy, and the change in the enthalpy as it goes through an isothermal or it goes through an adiabatic expansion, changing the volume from 15 atmospheres to 10 atmospheres. And we're given the molar heat capacity is equal to 3/2 of R. So let's zoom out and start working on this a little bit. So we've got T1, P1, V1, N1 is equal to 300 K, 15 atmospheres, 15 liters, and N is equal to PV over RT is equal to 15 over 8.2 times 10 to the minus 2 times 300 is equal to 9.15 mole. Having an isothermal change. That keeps temperature 2 equal to temperature 1. The pressure changes to 10 atmospheres because we're given that as part of the problem statement. It's a closed system, so the moles of gas in the system do not change. And then volume changes, and we can write that as P1 V1 over P2 is equal to 15 divided by 10 is equal to 22.5 liters. So that's whatever the first component we're looking for. Next, let's see, because it's isothermal, we now know that delta U is equal to 0 because it's an ideal gas, and that is equal to Q minus W. So we now have that Q equals W, and that's going to be equal to the integral P dV from V1 to V2 is equal to the integral V1 to V2 of nRT over V dV is equal to nRT log of V2 over V1, which in our case, Q equals W is equal to 9.15 times 8.314 times 300 times log of 22.5 divided by 15 is equal to 9253 joule. So that is part 2 and part 3 of the problem. We got part 4 the problem. So now we're doing part 5. The enthalpy delta H is equal to delta U plus delta PV is equal to 0 plus 225 minus 15 times 15 equals 0. Okay, so that's part A of the problem. Moving to part B. Part B is a reversible adiabatic expansion. So I have T1, P1, V1, K, 15 atmosphere, 15 liter, 9.15 mole, adiabatic, of T2, P2 is equal to 10 km, V2, and N2 is equal to 9.15 mole. Okay, well, since it's adiabatic, we have that P1 V1 to the gamma is equal to P2 V2 to the gamma, right? And that means V2 is equal to P1 V1 gamma over P2, all raised to the 1 over gamma. Gamma is equal to R over CV plus 1 is equal to 5/3, using that CV is equal to 3/2 R, and substituting here, we get 15 times 15 to the 5/3 over 10, all raised to the 3/5, which gives us a volume of 19.13 liters. And then temperature is simply PV over NR, and that is 10 times 19.13 over 9.15 times 8.2 times 10 to the minus 2 is equal to 255 K. Okay. So, we got the volume, which is one of the questions. Writing the first law, Q minus W, by definition of being adiabatic, Q equals 0. So that's question number 3, which means that now delta U is equal to negative W. And this is delta U is equal to minus W is equal to integral T1 to T2 N CV dt. All right, we're just using the heat capacity and internal energy relationship. That. Which means that du is equal to minus W is equal to 9.15 times 3/2 times 8.314 times 255 minus 300 is equal to minus 5135 joule. Okay, so that gives us work and internal energy, which are parts 2 and parts 4. And then finally, we have delta H is equal to delta U plus delta PV is equal to minus 5135 plus 10 times 19.13 minus 15 times 15, and this is liter atmosphere ATM. So we multiply this by 101 joule per liter atmosphere. We get delta H is equal to minus 8,539 joules. Okay.